Hello and welcome to the first session of Foundation Mathematics. This course is intended for people who completed grade 12 and are following a degree program in business studies, social sciences, or the hard sciences, where you're looking at the medical doctors, the engineers, the mathematicians, the chemists, the physicists. Each and every student that has been enrolled in the university has to do a foundation mathematics based on which program they are going to be doing. So now this course aims to give students mathematical concepts, knowledge and skills which will help them in the later courses. So we are going to begin this by reviewing the grade 12 work that we did at secondary school, where we begin by looking at the set theory, the relations and functions, as well as the theory of quadratic equations. I am your host, Upe Kolosa. So at the end of this course, what is expected of a student? As a student, we expect you to understand the basic concepts of mathematics. We also expect you to relate the basic mathematics that you are going to learn and relate them to the real life problems. We also expect you to apply the mathematics to business and economic problems. For those that are doing engineering, we expect you to apply them in the engineering field. As in the later courses, you are also going to do courses like engineering mathematics. So this is the foundation of your program. So we begin this by looking at the first unit of foundation mathematics, which is the set theory. So under set theory, we are going to look at the ways to describe a set. We're also going to look at the definitions and the notations of a set. So let's begin with the definition. How do we define what a set is? So in a layman's language, we say a set is basically going to be a composition of things. So you can consider you have a bucket. In that bucket, you have a cell phone. In the same bucket, you have an orange. In the same bucket, you have a drinking bottle. That bucket is a set. That is in a layman's language. But mathematically, that bucket is not defined as a set. So how do we define a set in mathematics? So when we are defining a set in mathematics, the key word that we have to have is the defined objects. So you're going to say a set is a collection of well-defined objects. So our key term here is the defined object. So how is this defined object different with the example that I gave of you having a drinking bottle, an orange, as well as a cell phone in a bucket? How is this defined object different from that? So by defined object, what we mean is, if you're having a bucket, that bucket should contain things of a similar nature. When you look at the phone, you look at the orange and the drinking bottle. In no ways are these three things related. So by defined objects, what you are expected to have, if you have in a bucket, you say an orange. In the same bucket, you're having an apple. In the same bucket, you have a banana. So you can see that these three things, they have something in common. And the common things, you are going to say the three are the fruits. Therefore, you are going to say you have a bucket of fruits. In other words, it is a set of fruits. Again, consider in a bucket you have an iPhone. In the same bucket, you have a Samsung or any other phone. So you are going to say that this second bucket, it is a collection of phones. So This is what we mean by defined objects. You should be able to identify each and everything that you have in the bucket, and the things in the bucket, they should relate in one way or the other. So these objects we're having in the bucket are now what we are calling the elements or the members of that set. Okay? So now we can now move on to define the characteristics of a set. What defines a set? So you're saying a set must be well defined. This is the first characteristic of a set from the definition itself. A set must be well defined. That means if you're having a set of fruits, it should be a set of fruits. If you're having a set of phones, it should be a set of phones. Then the other characteristics is that the elements in a set must be distinct. The elements in the set must be distinct. So here we can consider you have the set of numbers. You have one, you have the number 1, you have 2, 3, 4, you have 5, 2, and a 1. Consider this to be your set. So based on the second characteristic, this collection that we have here is not a set, because in this we already have a 1 which is also appearing here. We have a 2 which is also appearing at the far end there. So such a collection is not a set. So what we mean is each element must and should only appear once. If you have a 1, no, at any point should a 1 come in. So you should move to the next element, which is a 2, 3, a 4, and a 5. So this second collection is what defined a set, or it is the definition of the second characteristic, where we're saying the elements in a set must be distinct. Then the third and last characteristic of the set is that the order of elements in the set is not important. So we can use this same example of set B, of the basket B. We have 1, 2, 3, 4, 5. These are counting numbers that are in ascending order. Now, we are saying that for a set, it does not matter the particular order that you follow. This set B, or this collection B, can also be written as 2, 3, 1, 5, and a 4. And we can see that the elements that are in this collection, which we are calling C, are the same elements that we have in the collection B. And we are saying that the order of elements does not matter. Here we started with a 1, here we are starting with a 2. We are ending with a 5, we are ending with a 4. Therefore, the order of the elements does not matter. So these three are the characteristics of the set. So we can now move on to look at the symbols or the notations of a set. How do we denote a set? So a set is denoted by this collection. So consider this collection where we have set A is equal to, this is our collection of 1, 2, 3, and the 4. So before we go any further, also note that we are going to be using the capital letters to denote a set. So if you're having a set of letters, the letters or the elements that are going to be letters are going to be in small letters, like we have done here. So the capital letter A is representing a set. The small letters are representing the elements of the set. So now, again, going back to the symbols, we are saying, let this A be a set of these elements. So a set is denoted by the curly brackets here. Now, if you do not have any element 1, 2, 3, and 4, suppose this is your set without any element. This set is what is known as the empty set, which is also denoted by the symbol or the Greek symbol phi, written as P H I, to denote the empty set. Then from here, set A, we are saying it has the elements 1, 2, 3, and a 4. That implies that 2 belongs to set A. 4 belongs to set A. In other words, 1 is a member of set A. So mathematically, how do we write or how do we present that 1 is a member of A, 2 is the member of A? So this is where now we are using the elongated E, this symbol. It is the E that is elongated to represent that a particular elements belong to a particular set. So for example, you can say that 3, this 3 belongs to this set, which is set A. So you're going to say 3 is the member of A, or 3 belongs to A. If you take 5, does 5 belong to this set A? From there we can see that 5 is not part of set A. So you are going to say that 5 does not belong to A, or 5 is not the member of A. And the symbol we are going to use is the elongated E that has been cancelled to imply that this 5 does not belong to the set A. Then again we move on to the next notation, which is the subset. So the subset is used when you are talking about sets. The member of is used when you are talking about elements. We are using member of when we are dealing with the elements that are inside the set. But this subset is going to be used when you are talking about sets. That is 2 sets or 2 or more sets. So we already have set A there. Let's assume we have our set C, which is 1, 2, just 1 and 2 elements. Now, from this set C, we can see that the elements that are in set C, they are also the elements that are in set A. In other words, you can say that set A has 2 sets. You can take it that set A has 2 sets. The first set that it has is 1 and 2. The second set that it has is 3 and 4. You can take it that way. Now, so you can see that this set C, 1, 2, is part of set A. So you can say that set C is the subset of set A. And to represent the subset, this is where we are using this elongated C. So you are going to say that C is the subset of set A. Then you can ask yourself, is set A the subset of set C? So the elements in set A is 1, 2, 3, and 4. Do these elements also belong to set C? That's what we mean when we talk of subset. So we already have 1 and 2 that belongs to set C. However, 3 and 4 does not belong to set C. Therefore, you say that set A is not, again, we are going to cancel this subset, is not the subset of set C. So these are the basic notations that we are going to be using for the rest of this unit. I am your host, Upe Kolosa. Remember to like and subscribe to the channel for more videos of Foundation Mathematics. Next time we are going to meet, or in the next session, we are going to be looking at the ways of how you can describe a set.